Continuous Testing podcast. Today I'm joined by Paul Gerard. This is just after we've done at the CD Summit a joint session on digital assurance, which was focused around the pocketbook. But I'm sure people would be keen to kind of get a bit about the journey where you've come from and a bit about yourself, Paul.
Yeah, sure. So my background is as a developer, I have to say, since about early 80s, and I got into testing about 2-3 years ago, and like many people, almost by accident. But my background really is I focus on the more technical aspects nowadays. I've always had a technical bent, but for the last 15 years, most of my activity has been to do process consulting, process improvement, training, coaching, mentoring, that kind of game. Also, projects of all sizes to sort of do test strategies, open the door for a test manager and a team to follow, that kind of activity. In parallel with that, I've written one big book and a few smaller ones, and this is part of what we'll talk about today. The story about this little book, I should say, is CA kindly asked me to write some articles for them, which I thought was fantastic, because having a deadline helps me to get focused and to do the right thing, if you like. So I wrote a series of 5 articles on things like testers in the shift left kind of phenomenon that's happening now, Internet of Things, what I call the new model of testing, and so on. And having written them and thought they were quite good, I suggested maybe we could put them top and tail and put them into a little book and have a more rounded package on digital assurance, because digital is the big thing now. So it seemed opportune to try and put some of these ideas into one place, and Jonathan kindly did the forward and set the scene, if you like, and helped me put what I think is quite a nice little package together.
And it also is kind of worth mentioning this is kind of a series as well, because I remember the Tester's Pocketbook.
Yeah.
And obviously one of my favourites was the business story method as well. It was kind of building some of that stuff around. And I guess leading on from the business story method, the focus was moving to the business really, and how they would collaborate in these kind of activities. It wasn't just about test anymore.
Yeah.
And I think, as running the TMF since 2004, part of it, and it was, did you say, it's 60 sessions, forums you'd have?
Okay. It's the first one we ran. Well, there's a long story to that as well. Let me explain. I think it might help a little bit of context. The TMF was started when I worked with System WT back in the day. And we scratched our heads and said, well, we want to meet more senior people because we want to do business with them, of course, but partly we want to have more interesting conversations. And that was the driver. So we basically emailed a few of our testing friends and said, why don't we get together and talk about some interesting stuff and have a couple of beers after the end of the day. And it grew from that, from an informal group of about 15 people having a chat to what's now, we get to 50, 60, 70 people. We've run 54, I think is the number, I'm probably wrong, but 54 I think. We've been doing it for getting on for 14 years now. So, and it's kind of succeeded. But a recent change is one of the recurring stories was I'd get test managers, many times coming up to me and saying things like, I've been agile, where do I fit? Where's my role in the business? Mm-hmm. Because agile doesn't talk about test management at all. It has no place. So all these guys who are really smart professionals were sort of thinking, what do I do with myself? Mm-hmm. So what seems to have happened is several career moves seem possible. One is to become a kind of a more senior practitioner going to program test management if you're working on bigger projects, or into assurance, and we can talk about that in a moment, or get into a specialism like performance testing or more technical testing, or one of these games, or get out of testing completely, and there's quite a few people who've done that. At any rate, a recent change for the TMF is that we decided to, there are lots of testing meetups now, and I think one of the drivers for this was we wanted to get out of the melee of all these testing meetups, which are fantastic, and talk about more serious issues, sort of grown-up, if you like, issues. So we've changed the name, rebranded it to Assurance Leadership Forum now. And maybe let's talk about assurance, because that's kind of relevant. Assurance it's one of these things that's not well defined yet. And yet I feel that I've been working in assurance for 15 years or so. And kind of assurance is really about trying to get the best way of navigation through projects. That's one way of looking at it. So that what testers do is they gather information on product to allow other people to make decisions. So the assurance role in that context would be, have we got the right people advising and informing and influencing the testers to go and test the right stuff? Are we using the right mechanisms for arriving at a set of test cases or tests that have meaning? Are we delivering the right information to the stakeholders in good order? So is it in time for them to make sensible decisions? Is it not too much detail, not too little, just right, that kind of game? The whole notion of assurance is if you like, facilitating the way that information is captured by test to improve requirements, designs, the quality of components through developer testing, integration system, the whole shooting match. So it's kind of like a navigator role. It's like, are we seeing signs that the project is going off course a little bit sooner than waiting for a monthly report from a project manager? Okay.
So it's kind of the PPM stuff, but it's how it all feeds in. Because what I've seen in the industry is that tools have typically been test tools or development tools, and then you've had tools like Test Director, which had one purpose and one silo to fill.
Yeah.
And one of the problems with having a tool that was built just for testers was that it wasn't, developers were less encouraged to go in there. And obviously that moved up to the application lifecycle management tools next, which was saying, well, actually, yes, we've got to all collaborate as part of one of those principles, I guess, and therefore we need to work together. But again, it was kind of pigeoned into a project or an application. What we're seeing now is we're moving to these solutions, which is huge sets of applications that have dependencies on a particular domain. And I think to me, which is what the really exciting bit, and then part of the title is now we're into this, digital transformation, digital evolution, whatever you want to call it, where digital is becoming, multiple solutions, multiple vendors in part of mobile, whether it's Alexa, it's IoT, it's a much bigger dependency, and therefore adding assurance across that for Car2X and autonomous vehicles suddenly becomes not just one company's responsibility, but multiple companies that have to then exchange, some kind of level of assurance and confidence in what they're producing as part of a bigger problem.
Okay, that's a big. Is that a question? That's
a big question. Yeah.
So my response to that is yes, all the above. And so what? Let me sort of, in my own mind, tell what I think is the story of software development the last 15 years when Agile kind of arrived on the scene. And Agile was a response to all that complication of dealing with larger projects, typically requirements that were cast in stone, which were never right, and coping with the fallout from having processes which were inflexible. So Agile was a response to that. We reduce the scale of what we're trying to achieve. We bring more adaptive, if you like, activity within the process. We give everyone the right to give good feedback and give it regularly, and we enforce it almost through things like Scrum and daily stand-ups. We force people almost to talk to each other. And through that, if there's one thing we learned from agility, is it's about rapid feedback. So rapid feedback on small issues before they become huge later on, kind of thing. Now, one of the problems we had is if we look at the technologies that existed 15 years ago, most of which still do exist and still dominate the marketplace to support these activities, things like ALM, without naming a particular product or whatever, is a response to the corporate project, program-wide management attempt to control this beast that that they call big projects. So the tools that align with those things are kind of what's the word? They make life less flexible. So what seems to be happening now is companies have decided to take on the agile kind of philosophy. They are now moving closer towards the whole idea of continuous delivery, DevOps. These things sound very attractive because kind of they're breaking down barriers, and they're saying, well, we should take big projects, break them down into sub-small sizes that we can almost guarantee delivery in our month, fortnight, daily delivery, whatever it happens to be. As a consequence, my argument with the testing kind of community, or to the testing community, not with them, is to say the old ways of thinking don't work. So we can't think in terms of stages anymore. We have to treat testing as a continuous process, like breathing. It's non-stop, it's pervasive, it's everywhere. And so a lot of the initiatives that are out there, I think, align very nicely with this notion of continuity and continuousness, if there's such a word. So the idea of the new model in the book, is to say, since we cannot predict, or I cannot predict from the top of the mountain how people are going to work, you have to say, strip away all the what I would call logistical stuff that people do that gets in the way of agility, firstly, and also continuous delivery and DevOps and those things. And the things that I would call logistics are things like documenting your tests. I would say I don't care whether you document them or not. That's not part of testing. That's a piece of logistics. Yeah. Same goes with whether you use a piece of technology to run your tests, or whether you have a team of people using their hands, eyes, feet, noses, whatever, and everything in between. So I'd say take that out of the equation, and so on and so forth. The technology you use is not relevant to the way you think, because I have to say that I think testing is not a hands-on activity. It's a thinking, it's an intellectual activity, which some would say that's being a little bit pompous. Well, so be it. It is what it is. So in order to react to a very rapidly changing environment that digital is forcing on us, with all these changes in our processes happening almost daily, we have to step back and just understand very clearly what our thought processes are. And then when we encounter a new situation to deal with, then we use that process to build our new approach. Okay, so given the complicated DevOps processes that people are now putting on a wall, filling a wall with, and then saying we're going to automate all this stuff, or that's the goal, ultimately, to have a sausage machine where you feed requirements in and software that works comes out. All these component processes that are in there, many of them that do useful work, need a shadow test activity, of which some are going to be very simple. There's going to be a simple check, so it has this task finished. But some will be, well, here's the build process, well, now let's have a set of tests which stress the build itself to tell us it's a coherent, integral piece of software that can be tested later. So I would argue that many of the DevOps processes, the test processes that are in the DevOps processes are actually there to check other DevOps processes. So the way I look at it is you have DevOps processes and then you have testing overlaid.
So this kind of leads into what I was kind of mentioning through the session about this kind of test in DevOps, instead of moving into this, which was, as you said, you were a developer, but kind of this developer in test, which was kind of saying, okay, sit down with the development team, be part of that development activity. And in those kind of agile practices was great. But when it comes to Scrum of Scrum, SAFe, when you're scaling that, sometimes that model doesn't scale. Whereas what we're talking about with the factory level is we're talking about things like lean engineering, we're looking at reducing the waste, we're looking at reducing the handoff times. Therefore, you can't have a tester dedicated to testing the release pipe or the infrastructure as code, configuration as code. It's an activity that is part of that think, make, check, which therefore they need testing capabilities or activity for the tools, which could be anything. They could be your Chef, Puppet, orchestration engines. They could be your build process using Jenkins, Hudson, Team City. It doesn't really matter. What you've got to do is wrap some kind of quality around that as far as repeatability, being able to measure it in some particular way. And that's difficult because these systems are all not connected. They've all got their own reporting engines, and therefore, from an analytics point of view, and getting some information to give you some kind of level of confidence that you can repeat the process again and get similar kind of outputs, it's quite hard to connect this huge ecosystem of tools. And I think that was another thing that we talked about today around some of the work that you've been doing with kind of TK base. Is looking at just the sheer amount of different tools that a tester or a developer or the old traditional roles, but also these new roles which you're coming to see through.
A big questioning. So the things that I picked up on there were partly how, if you look at your DevOps processes, let's say you start from scratch and say we as a company are going to go DevOps, whatever that means. And you sketch out your processes on the wall, and you have a big wall covered in blobs with lines joining them and stuff like that. Many of them will be to do with development activities, build activities, deployment, setting up environments, doing this, and then you have these tests which occur at various places. And you can say, we can automate all this, and everyone will say, or nod sagely and say, let's pick our tools and put your tools in there. And then someone in the corner, one of the testers says, how do we automate test design? Well, just get your tool. Well, there are no tools to do your test design for you. There's tools to prepare data, to execute tests, to do analyses of the outcomes of tests. We can do performance tests, we do this, do that. But the design of tests, of good tests, so running tests is easy. Running 1 million tests is dead easy. Who designs the 1 million tests? How do we do this? So that's why I put modelling at the heart of this, because modelling is basically the foundation of good test design. And what we need to think about much more carefully, and this is part of what the new model testing is about, is to say modelling is the core activity of testing. Everything else is logistics. We can use tools for many of the other activities, or we don't need them at all. We don't need to produce manuals of documentation because our tools tell us what they are doing. So how do we get this modelling activity in there? Well, partly, this is what shift left is, in that when we see a requirement for the very first time, we mentally model it, we think about building it as a developer, we think about testing it as a tester. So development and test development kind of work hand in hand, it should work in parallel. And to me, that's the core of shift left. The people who are building stuff need to be using models which are at least consistent with the models for the people who are testing stuff. It's the shift left thing makes this possible. So DevOps is impossible without shift left and testers doing their thinking in the time they've got, not the time they haven't got.
So let me just blur the lines for a second. So, Dan North spoke yesterday about the fact that we like the silos. There's a lot of politics in organisations. People like to own their area and feel comfortable within their own little castle. Now, part of what we're by blurring those lines, and you're looking at new roles, part of cross-functional roles. So, when my experience with DevOps, when I've seen it in organisations, sometimes you get these new personas through, like researchers. Somebody who looks at models the requirement, understands it, interprets it, and then says, well, actually, should it ever be built? Is it something that we could consume instead of building? But part of it is they're looking and saying, we're not going to reinvent the wheel again. Yep. Therefore, maybe we'll change. And you've got experienced consultants. I think you mentioned it slightly earlier today, where sometimes you build into a vision about what you whiteboard it onto a big wall, saying, well, this is our customer journey, or this is the customer experience or the digital experience, end to end, whether it be talking to Alexa to ask for to order something through. This is part of a journey and a vision we believe we want to buy into. They come out and do things like lean UX and different practices which are very different. So rapid prototyping, proving hypotheses of an idea before they go into the build stage, and so therefore these roles are changing. And I believe that testers have a place in that. And I think we talked about some of the skills, which maybe not in the ISTQB, which are critical thinking and stuff that are applying patterns, but first taking those kind of thoughts of understanding if a requirement's ambiguous, challenging that requirement. So do you think they need to extend it from an industry point of view to understand that actually testing, like you said, is a thinking component, but also that maybe there's some skills, some creative skills and communication skills and some trust exercises that maybe they need to start looking at?
Yes, again. I think, to me, again, just to respond to that in the round, if you like, is one of the things that we have as a problem in the testing community is too many people who are working as testers and too many people who hire and manage testers think testing is about finding bugs and finding bugs only. And yet, the thought processes that a tester goes through are so much more valuable and have so much more leverage if they're brought in early. And people like me have been saying this for 25 years, and like everywhere you look, every book on testing you ever see, it says test early, test often. And so you could say, well, that's just shift left. Now it seems to be fashionable. Hooray, hallelujah. It's not new, not new. So we have a contribution to make at the start. And that contribution at the start is to do with things like doing research, what I would call exploration of your sources of knowledge, which might be people, requirements, the old system, the new system, and you bring with that your own prejudices, biases, and all the other baggage, which you have to sort of pay some attention to, but hopefully not too much. And you have to formulate some kind of understanding of all these sometimes partial, incomplete, ambiguous, incorrect, conflicting sources of information. And so the tester trying to get all this stuff in their head, they have an opportunity to say, you know what, this doesn't work for me in some informal or formal way. And so the whole idea of modelling is that you can use a model to assimilate and build a picture, a vision of what the system should do. You can use that vision to make predictions, and that's the critical thing. When you understand how a system should work, you can now say, well, if this is the case, then that should happen. So what you can then do is then use examples which expose flaws in the requirements. You can use those examples to challenge your sources and say, I've just noticed if I do A, B and C, are you sure D, E and F are the right thing for this system to do? And the user will have one of several responses. That's absolutely fine. To, oh my God, we need to do a complete rethink of the requirements. You found a terrible problem in our thinking, and everything in between. So the contribution starts early. And you mentioned skilled, and what I did is I don't think it's in the book actually, but it's on somewhere on my website. But I made a list of skills, and they include things like critical thinking, needless to say, but stuff like Socratic questioning, which is a favourite of mine, which is essentially asking questions you know the answers to. And this is exactly what lawyers do in a courtroom. They never ask a question they don't know the answer to. They want the other person to take the question, to think about it, and to answer it. And by so doing, they then admit guilt or confusion over their own requirements. And so Socratic questioning is, like, to me, one of the most valuable things a tester can do. And we all try it every now and then. None of these skills are in the certification scheme. So it's a criticism of them, but they tend to focus on the things that are more standardized, like bug reporting and test case documentation, or whatever. The things that I would suggest are logistics that have great value in many contexts, but none of them will make you a better tester. They will just make you a better documenter or a better bug reporter, or and these are important skills, but they're not going to help your thinking, thought processes, and that's kind of where I'm coming from.
So I'll sidetrack you a little bit there, because I'm going to move a little bit into the realm of my kind of crazy, ludicrous kind of, as Hugh mentioned yesterday, kind of technology landscape. And I spent a bit of time yesterday talking to James Whittaker at Microsoft, and part of that where he's talking about the future and how things are going to change and how AI and bots and all this stuff is going to change. And I think the bots one I just wanted to take as a bit of a sidetrack. So I was lucky to kind of go through, and obviously Microsoft have just created something called Microsoft Teams, which is a Slack replacement for them. Okay. So part of that is that whole collaboration is, I want to ask you a question, is A and B equal C, but then I want to be able to ask that into a group, not just send it in an email, which is quite a legacy way of doing things, or walk over, have that communication conversation, but only be the person with the source of knowledge. Part of it is opening that up and collaborating as a team. Now, partly what we've seen with bots, and I looked at Lewis, which is a language learning AI-based platform they've done, which reads in sources of documents and knowledge so that the bot can become smarter, so it understands the context of whatever that organization. So if that's a pizza ordering company, it understands that you can't have a pepperoni passion or something and take off the pepperoni because it's no longer a pepperoni passion. So part of it is it understands it and it models it, so that is some understanding, and what you get is the model.
Yep.
But at the same time, I think we were talking, and one of your pet projects which you've been doing in the chat ops kind of sense is, how do these kind of tools and bots are actually going to start helping assist testers or testing as an activity, and give them some sources of knowledge, help them do some exploratory and guide them in the direction based on potential code changes, what's happened, changes in the logic that's happened. Do you think you're going to start seeing those kind of platforms? Alexa, asking Alexa for help. Where do you see this stuff going in the distant future?
Well, I think I put together a talk about 5 or 6 months ago and wrote a paper which basically talked about I can't remember exactly, will robots replace testers? And my conclusion was no. However, there is application for, let's say, more intelligent apps or applications to support specific activities in the process of testing. So one is capturing the model. So if in an exploratory testing session, or I would say any testing session, where you're exploring to understand what a system looks like, whatever, the kind of things that you would do in a sophisticated exploratory tester way would be to have a notebook by your side and making notes all the time. So I started from the position when I built my little bot, which is it's one of these little hobby sidelines, but the vision there was like, I don't want to be writing stuff down while I'm testing. I just want to, like an autopsy where the doctor has their hands in the body. You can't write things down, you speak and then it's transcribed. Well, I want to speak to an Alexa or equivalent, some kind of bot which understands what I'm saying, but as I'm doing my exploration, it's drawing the map. So just like if I was exploring a place, a building like the one we're in, full of rooms of all sizes, shapes and forms, well, as you go from room to room, from feature to feature, I'm going to say what I see, and I want the bot to draw the plan. So that when my colleague comes into the same system, he can say, show me the plan of this feature. And they see exactly what I discovered. And what I also want to see is, like, if I can get the bot to say, okay, give me a list of all the fields on this form. Give me some understanding of what validations are going on in the form. Read the JavaScript, tell me what the JavaScript does. These things are possible, not far off. So actually, what I get then is like a template in which to put my tests. So as I run my tests, I can say, I'm saying, these are the data fields as I patch them in. I expect to see a logged in message. I should be on the home page. Have you got that? Yeah, okay. Oh, it doesn't work. Oh, that's a bug, isn't it? Or maybe not. And then the bot is there doing a slave's job, capturing information that is in volumes I can't type.
Yeah.
But it's also going to turn around and say, actually, Joe tested this yesterday. He had the same problem. We haven't been able to reproduce it. What did you just do differently? And then you say, well, I'm not sure.
Tell me where I've been.
Tell me where I've been. What did he do? Show me his path of execution, and then show me overlay mine. That's what I want to see. And you're almost like, you can imagine, it's like a computer game. And again, James, he did talk about this 5 years ago.
5 years ago. So bringing James back into it. So actually, I got James to put. I've got a quote coming on a book that's coming out next month, and I said to James, which is why I was chatting to him. I said, look, I've got this quote which said, you said at ADP 5 years ago in Vegas, you said there'll be no apps in 5 years' time, and kind of what the whole reason behind that was led to this book, which I talked around. It's about digital experiences. And I was saying, well, actually, customer experiences where you interact with an application and you order a book or you do something like that. Yes, that's absolutely relevant in the kind of in the current state of the factory. But actually, what you're going to see in the future is Alexa, or you ask to get a book, or even Alexa knows that you want the book because you've sat down and want to read your book, so it just goes off and orders it. So there's kind of some predictive, prescriptive, all that stuff, but more in the IoT where bots are talking to other bots, because it's negotiating a price of a direct to you to print the book instead of going through a bookstore or finding you a second-hand copy of it. These are all going to be individual bots with very limited interactions and UIs. So part of it is this whole IoT, which I think we were moving on to anyway. The Internet of Things means that the rapid amount of machine-to-machine interactions. There's going to be a role for testers in there, and they may be panicking because there's no UI, there's no field to validate. There is lots of digital interactions and machine learning and artificial intelligence and big data, where they're going to be, like the Monte Carlo algorithm, they'll be running the same script in the same way with the same data, getting two different results, and then panicking because they're going to be like, well, I can't reproduce this because it's extremely complex. It's based on a moment in time where, at this point in time with Brexit or the rate, things change. You order the same book 30 seconds later and it goes through a different path to find the best way of getting it. So how are they going to deal with this new landscape of IoT and beyond?
I think this is the $64,000 question for the IoT. I mean, right here, right now, most people think of the IoT as things like a couple of makers working in their back bedroom, making a little device that's going to help you to plant your bulbs in the garden in October, whatever. That's no problem. That's not our problem. The problem comes with things like smart cities, where everyone has to integrate their wonderful little gadget into a smart city. A smart city is a system or system of systems, or what was your phrase? The
ecosystem of
ecosystems. Yeah. It's like, well, how many systems can we get? So a typical challenge will be, although it won't be something well, maybe you get involved in more than I do, but someone has to do this test, which is, okay, we have a city full of traditional cars, real drivers, real people, plus we're going to add 100,000 self-driving cars. And they all work. We're all happy the self-driving cars are safe. We've got to that point. But how do we do the traffic management? How do we test the traffic management of a city with, say, 1 million traditional cars, and you could say a few hundred, or it could be a few 100,000 self-driving cars? How are we going to test that? That the city infrastructure and everything involved around it works. Well, you could say, okay, well, what we'll do is we'll create test cases like these million cars are going to go from A to B, or A to Z, or Z to A, all around the city, and we're going to say go, and they all set off, and oh my God, within about a millisecond, we've got 80 gigabytes of outputs from our sensors. Because our sensors are all set up to tell us what's going on constantly. And is that right? Are we going to look through these by hand? What are we going to do? So I think that I'm not saying the solution, but the thinking we have to do is to say, forget that. We're just going to have to run it as a simulation and think simulation rather than testing, and say, okay, of the 1 million cars, we're going to take examples and track them very closely. So we might take 1,000 cars that we follow very closely, and our expected result is no collisions, no driving through walls, through red lights, one-way streets, no dead people. Everyone gets to their destination in the time Google predicted, within plus or minus 10%. So you run your simulation, which takes either a minute or a year, who knows, I don't know. And then you say, have we found any of these anomalies? Now, at one level, that's the only way we can test today. Now, in order to test in a more sophisticated way, that's quite sophisticated. It's probably better than most people will do anyway.
So let me just jump in there a little bit. So obviously we've got a case study around smart cities and the smart city project in Copenhagen, which you know about. And I'll give a bit of context around this, because I kind of sat in that car2x kind of landscape a little bit, so I see what's happening. As we were just saying, autonomous vehicles, great, but it's autonomous, right? The thing is, it's self-contained. It's not talking to.
It's not predictable.
So it's on its own, and it's based on one technology versus another technology, how they implement that. Once you connect the car to something like car2x, infrastructure to X, so it's talking to the street lamps, so that it knows when to start and stop and go, and which car should take priority over which car. Then you add in the human element, and we both know, Chris Ambler, the fact that you look at those kind of things like EA and Microsoft, who've got this huge complex virtual environments, which they've done for things like SimCity, and we think, well, actually, you can take some of that simulation, some of the rules that they created within the virtual worlds. So we're talking about VR, MR, which is multi-reality, and AR. You're suddenly overlaying some of these tools which people are going to test. James Whittaker mentioned yesterday about things like Pokemon. We did a podcast around modelling out Pokemon using a modelling tool, and then generating all the possible paths, but also driving a phone at the end, which actually was using the crowd testing, knowing where the Pokemon were, but actually taking the GPX route to go and then catch the Pokemon, driving an actual mobile device. Now that's a bit of a party trick, but it's a real example. But in the case of what we actually did in the case study was for Copenhagen, we went and got so it was a bit of crowd test. We got the university's students to go around, turn on their GPX logger, and do their normal routes. So what we had is a delta, like you said, with the small amount of cars, the delta, which was people going on tubes, people having bicycles, and we had a lot of GPX information. And then what we took that and synthetically generated 2 billion historical transactions into a big data kind of platform, which didn't exist. So the city didn't have 2 billion, transactions of people walking around the city, and we had to take a subset of a larger and then synthesize all that stuff. But once we got that big data store, we were able to do things like gamification, and then start testing devices that thought they were walking around by modeling car goes to A to B to C, all running at the same time, all sending messages to say, which way should I turn? What's the most carbon neutral way for me to get to work? These kind of smart city applications, which we'll all take for granted in the future, which are going to say, this is the car parking availability for the entire city, not individual areas, and your car will, with a connected car, will negotiate the best car parking space in the town and the best route to get to for the different things that you need to do, such as a meeting. And then as the meeting route comes through, it's been changed to different locations, you remap, go and negotiate, release that parking space, go to another parking space. But these are hugely complex systems, and I think we've also got, which is obviously part of probably the next book, but the digital assurance book talks about drones and IoT and these large complex systems, and they're coming faster than I think anyone's prepared for.
Yeah. So the first thing I'd say after all that, which is like absolutely what I think is happening, it's not visible to so many people, but companies like you are seeing customers, clients who are doing incredibly ambitious things or trying to do incredibly ambitious things, and the first thing I have to say is there's not going to be any lack of demand for testers and testing. First off, yes, most of it will be automated, but if 99% is automated, that still leaves enough for all of us to do manually. So there's no shortage of problem, no shortage of work there. But the core of all these things is at whatever application level, there's this constant, which is a modelling activity to understand, from some perspective, this complexity. And all modelling does is it takes a view through, horizontally, vertically, by some slicing mechanism, whatever it is, that's part of your model, to take a simplified view that a human being can understand and say, that allows me to check something of interest. Now, so again, things I've done in the past, I think, good heavens, that was useful to me about 25 years ago when I was a developer. One of them was like, how do you test a piece of software which does a terribly complex calculation, gives you a number, and you say, is that number correct or not? You've got to do the same calculation by hand. And I remember what we did is there's about 50 variables going into this calculation, and as a single number comes out, and it's almost like a yes, no. You think, well, is that correct? How do we know? To do the calculation by hand, even with Excel, whatever, was like terribly, terribly painful. So the solution we came up with was, or a partial solution, was to say, what we'll do is we'll calculate a correct result once, and then we'll change one thing, and we'll see how that affects the answer. And then we'll use our engineering instincts. Well, is it changing it in the right direction? Yes, no. Yes, okay. Is it changing it proportionally? Well, okay, so we'll add 1% and see what the effect. We'll add 10%, 20%. Is it going in the right direction? So kind of we're doing calculus. I don't know if you do calculus at school, doing little deltas and whatever. Is the rate of change of our output consistent with the rate of change of our input, and kind of thing. Now, where did that come from? That came from A-level maths in the bloody 70s for me, and yet that was one source. We're going to have to create hundreds of different ways of modelling these things.
Mathematical models.
Maths is going to be part of it, absolutely.
It's the only universal language. Which I know if Hugh was here, he'd tell two things. So another thing which we're doing with some of the big customers at the moment. So one of the big iPhone, the big phone providers is they're looking at providing the expected result. Now, I'm not saying this isn't a case of you press this and this happens. I'm saying if you do 50,000 transactions and you order all this stuff and the system works in a certain way, the ETL at the end of the day will have 400 new tables, which we're populated in some kind of XDoc file for an ERP system. So we're talking about many complex,
absolutely,
math models that he's building, and part of what that means is, and to me, it's virtualization in the sense that if you don't do database virtualization, then you can't control that. No other testers are collaborating and changing it so that the expected result that happens 50 minutes down the line here will be that total of 42, what you expected at the end point. So we're looking at this stuff, but I think we talked about today the pinpoint failure analysis stuff, and or as what I call the infinite probability drive, as moving to back to the Hitchhiker's Guide to the Galaxy, was that what we're doing is we're taking all those learnings of what we thought, what our hypothesis was, and we're taking it back and we're saying, okay, let's now, what other possibilities of should we be going exploring on? How do we go root cause analysis on those particular problems, and then generate some more tests to go down? Because I think we're not going to get into the Michael Bolton, James kind of conversation of saying testing versus checking. We understand that automation checks, but we don't want to generate 10,000 different possibilities for a simulation by hand in Excel. No. There's going to be a lot of this, like I said, the 99.5%, which will be generated by these models at the heart. But there will be somebody who has to interpret them. There'll be a place for them to understand. Well, why are we doing this? What's the value in us doing this for our customer? And to me, when we talk about digital, which was kind of the whole point around the book really was it's disruption. You know, part of, and I'm not going to mention any of the organisations which you associate with digital, is that you're having organisations that come into a space what's not being disrupted. The fintechs come into areas where they're disrupting the industry, but the banking industry, but you know, it's such a complex space to be. If you move to other countries like Australia, you know, they disrupt themselves. So they do the Kickstarter, the startup, the lean startup stuff, because they rather disrupt themselves and create the fintech technology than wait for a competitor to come in. Now, for me, the big thing about digital was, well, how quickly can you respond? How quickly can you pivot as an organisation? The large-scale organisations, which is, we're not going to have much time for dev and ops, but you know, being able to pivot your business model to compete directly with those fintechs and not be releasing on the average time for a non-digital organisation is up to 18 months to respond to a disruption, which could be a dynamic pricing, it could be a way to offer a platform which you don't have yet. For you to be able to get to that point where you can not let them eat your part of your customer base, you're going to have to respond. And if that means being able to release things much faster than those yearly release cycles from the old V model kind of days, you know, even with Agile and changing, you know, one day you're selling pizzas, the next day you're selling menswear because you see that there's a new opportunity in the marketplace. This is going to be a big challenge for most organisations.
Well, I think one of the reasons that Agile has been hard to implement for many organisations is the cultural challenge. That people aren't used to having daily stand-ups. They like monthly meetings and so on, and all this kind of other baggage that big companies have, you know, well known. In the same way, we have the testing community has the same kind of baggage in terms of we still think in a stage structured way. And it came out in the session we did. It's like, are we shifting left, right, up, down, sideways, you know, it's pervasive. Okay, it's pervasive, but also we're going to be testing systems that don't have systems that come from a project which has a start, a middle, and an end, or a start, a middle, and an end. Take your pick. We're going to be testing systems that actually it's a different system yesterday to today, and it'll be different again tomorrow. And you've got to test. Well, it's almost like an organic process. Now, this is a bit science fiction-y, but you can see this is the vision that people in the digital world are having, that's where they want to be. So, as another parallel thread is it's not digital, but there's been lots of talk in the last couple of years about bots and software, often taking 48% of the jobs in the USA, and Europe and all the Western countries, nations. Which is like, I think that's a bit scarier than it should be, but let's say it was just 10%. That's, I don't know how many people work in the UK, about 3-4 million people, 10% of the workforce doing completely different jobs. I mean, jobs that don't exist now, and the jobs they used to do not exist anymore for people. Yeah. That's a hell of a cultural and a social change, and it's, we're getting into bigger issues here, but that's the world we're in now. Yeah. And we're going to be testing functionality and security and all the good old, bad old, performance and usability. We're going to be doing all that stuff, but we're also going to be testing things like what's the impact on society, and if you think the most troublesome problem that testers sometimes have is like, how do you test the most valuable aspects of a product? How do you deliver the most valuable aspects of a product? It's very hard to put a price, a single number, to put a value on it. That's hard. How are we going to put values on the social impact on a system that we're putting out? So the functionality and the software and the package, it might be, we all know works. A bit like SAP. SAP works. It has this Teutonic certainty. It doesn't have bugs, I'm sure, but by and large, you don't find bugs in SAP. The bugs come when people get involved and configure it, and then they go and do what people do, which is not behave themselves. In the same way, when you're testing a smart city, most of your test cases aren't going to be about autonomous cars. It's going to be people not following the rules of the road in an environment where there are autonomous cars. So the cars can negotiate the best route to go through the city, and get its parking spot allocated. It's ready to go, and then some clown has just parked there because they don't know the rules, or they're just a kid and they don't understand how to deal with rules in the city. And then what happens? This car is going to feel terribly aggrieved. What's it going to do? It's going to shuffle its requirement all along the chain. So then you have the problem of, it's not about calculating the allocation or the market, you could say, for car parking spaces. It's about running a real-time recalculation, renegotiation, recalibration endlessly, which is like, I think Google, I can't remember the exact context now, but when they do some of their searching algorithms, the data, the learnings they use, they're doing analyses 50,000 times a day.
Yeah.
That's what we're going to be testing. We're going to be running not 50,000 tests, we're going to run all our tests 50,000 times a day. That potentially is where we're headed, which is like, whoa, well, who's ever done this before?
Well, this was the kind of the big, and I think, so Gartner refers to it as algorithmic-based businesses, which is the whole thing, is a lot of these rules will be based on continuously evolving business, which will make decisions on product lines, what people buy, what people consume, how they navigate through cities. They'll change that. They already do that now. With things like CO2 emissions, they'll green light certain lorries, so they purposely tracking them so that they don't have to slow down. They're using less carbon footprint. These things are going to happen, but there's going to be people who break the laws. There's people who are going to break the system, which is kind of where we sit within that kind of testing area. So those systems of intelligence are going to start happening, and where the predictive and prescriptive analytics stuff comes in, and AI and all that great stuff they're all going to be tools. My good friend Theo, who writes for Forbes and a few other things, he talks about last year there was an app for that. Now there's an AI for that. You're going to get these things, which testers will be sat there going, well, they apply this AI, and then they apply that AI, and then we get this output, and then I've got to make a judgment about whether or not that's right. I've got to have some kind of confidence. Things are going to get more complex. We know that. I think part of where the book is kind of directing is saying, yes, things are getting complex. We don't have all the answers yet.
Very few.
We've got very few of the answers, but what we're trying to do is kind of give some kind of order to that chaos and some kind of level of assurance across there to say, well, actually, we're not just making this stuff up as we go along, hopefully, but actually what we're going to be doing is trying to understand. And the last two podcasts, we've had the last one that's just gone through, which was from Eric Simmons, was around the value-driven stuff, so understanding and trying to quantify some of that value. And then before that, Ray Arel did the one around solutions thinking. And I think this is where we're going into. We both know Emma Langdon, Dr. Emma Langdon, who's a lot of systems thinking. You've got to apply those things because there's laws of chaos which are going to apply to that, where things are going to get infinitely more complex. And those 10% of the workforce that's going to be redeployed into new challenging areas, it's going to be using your brain. It's going to be thinking about modelling, because it's something we do. You ride a bike because you've learned the model before. And apparently the people who go to Microsoft all ride a bike because it gives them more time to be thinking about other problems they're trying to solve than if they were having to drive a car or engage with some more complex based tasks as humans. I think we're going to evolve as a species, but we're evolving the tools, we're evolving the processes and the patterns that we apply. And I think this is the thing, we're going to be thinking a lot more and this is a new challenge which some people might not feel comfortable. As you said, they might be great at doing classification trees and applying this procedure, but in the procedure, in the context of what we're looking at now for some of these highly complex systems, this is going to be a new challenge for everybody.
I think so. I think it brings me back to the whole background to the new model, in that we don't know what's coming next. And there's a kind of a generational thing. There's a generation of testers up to date where the big challenge has been, crikey, when I look at this screen, there's a gazillion combinations I could test. I modelled in order to reduce it to a small number. What the next challenge will be, I think, the next generation, let's say, of thinking there has to be, is to say, well, we've got that problem, the combinatorial problem, but by the way, the software that you're testing is is evolving, self-healing, self-changing, self-whatever. How are you going to deal with an infinite number of test cases, an infinite horizon of versions? Because you could say every version of the software is a new version of the software. So hold on, are we going to have a complete rebuild, retest everything every millisecond as the software changes? We're going to have to think more carefully about what this is.
That's why they need the infinity probability drive, you see. This is why we're thinking ahead. And it's compute power, because that's what the cloud was. But we're not dealing with massive compute cycles at the moment, because we're not doing any thinking. We're doing, like you said, the executing side, and we're not spending that much time about the thinking side of things.
So I think one of the goals of the model is to get you thinking about breaking down exactly how you think about testing, because it's going to be humans who are, they may not be creating the million tests, but they'll be creating the mechanism to create the million tests. So I think what you will see in 25 years' time, when you might still be around, but I'll probably not be testing. I don't think so. I hope not. God, well, we'll see. Let's see. Is I think you will have a much smaller number of testers, and they will have the most fantastic tools we could only dream of, say a few years ago. Now we're thinking it's a dream, but they will come. So I think you'll have testers who can sit down and say, right, I'm going to create 1 million tests today, everyone completely unique, informative, and viable as a useful test. And bingo, and that's what you get. And we'll be thinking in terms of models, because partly our brains are fantastic modelling engines. You know, I'm sure I've had that conversation with you before, but we don't use it. We use it to do the most boring, mundane things and call that testing. And I think that's where we're at the moment. It's that we haven't even started doing testing properly, because the things we're going to be testing in the future are going to be so mega complex that we cannot do it with our own brains, but we have to get our brains in the right gear to start with. We can't even think of doing these things manually. So we want technology everywhere. And it brings me back to the whole DevOps thing. Is you can't have a fully automated pipeline with some manual interventions to say, oh, I need to think about creating some test cases. No way, you can't do that. So we've got to figure out a way of getting our models figured out before, or at least in time, to allow us to have these pipelines, these delivery pipelines. If continuous delivery and delivery pipelines are going in 25 years' time, well, which is debatable.
Because I think we said about the whole no-ops side of things, and SecOps and IoT ops, forget all that stuff for a second. Part of it is blurring the lines. And I think in the ops stuff, and Dan Mill said this yesterday, part of the ops is, we should be taking those learnings. When I last spoke to Alan Page from Microsoft, who did the How Microsoft Test, what he talked about was the difference between 5 years ago and today is that they know what's happening with their customers. They get that instant feedback because they don't wait till they've released an application. They're all doing the canary rollouts. They're looking and learning from what's going on.
I think they call it data-driven development. It's like, it's probably less kind of sexy than analytics and that kind of game, but they've been doing that for some time. Like all the big online businesses have. They've been doing analytics, but they just didn't call it analytics. No. So when James and others from Google were saying testing is dead, they were kind of predicting kind of where we are now. Yeah. Testing is not dead, but the old way of testing is dying very quickly.
And on that bombshell, I think we probably need to